Okay, so now let's look at actually solving compound inequalities with and or. So let's look at this first example. So the question is, find solutions of x that satisfy x greater than 2 and x less than -2. So let's look at x greater than -2, or greater than 2, sorry. So here's 2. Greater than, so not going to include, and greater than 2 is going to be up here. Okay, so this is where x is going to live for that inequality. Now, the other inequality is x less than -2. So here's -2, does not include it, and it's values of x that are less than that. Okay, so we just did number lines for each of these independently, but we're looking for solutions where both of these are being satisfied. So what we're looking for is we're looking for overlap between these two inequalities. And as we look and we see here, we see that there's actually no overlap. There's nowhere there's nowhere up above where this inequality exists, and there's nowhere down below where this inequality exists. So there's no overlap. So this is going to be an example, actually, of where there are no solutions, because there's no overlap between solution domains. So let's look at this OR example. So we've got the same inequalities as before, but now they're being joined by OR. So let's go ahead and just draw these in. Okay, so now with OR, this means we would be happy to have values of x in this domain or in this domain. So in this case, with OR, non-overlapping is okay. So the solution then is going to be both values of x that are less than -2 and values of x that are greater than 2. And so when we write this in interval notation, over here on the left, this domain of solutions on the left would be represented by this interval. And the domain of solutions for the interval on the right with 2 and greater would look like that. And we can use what's called union, okay, which is kind of what looks a little bit like a capital U, okay, without the serif. Okay, and when we use a union symbol between two intervals, that means we're joining these two domains. So this union joins these two domains. So a value of x in here would satisfy our original compound inequality. So for example, if we chose x equals 3, so if we had x equals 3, is x equals 3 greater than 2 or less than -2? It is. X equals 3 is greater than 2. So we're okay. When we say or, that means it's not necessary for this other condition, this other inequality to be satisfied. Okay. Let's look at some more examples here. All right, so this is an and. So find solutions of x that satisfy x greater than 2 and x greater than -2. Okay, so first we're going to graph x greater than 2. So there's x greater than 2. And now we're going to graph x greater than -2. So here's -2, not including. And now we're looking for values of x that are greater than 2. So now notice now that we're dealing with and, we're looking for overlap. So where do these two domains overlap? Well, if we kind of draw down to this point, where's the overlapping taking place? The overlapping is taking place is here above 2 and here above 2. Okay, the overlap does not include 2, because even though 2 exists in this inequality, 2 does not exist here in this equality. So we're looking for values of x specifically that satisfy both at the same time. So our solution for values of x that are going to be greater than 2 and greater than -2 is going to be only greater than 2. So this interval, this solution, these values of x are going to be from 2 to infinity. All right, let's look at another example. So this is or. So again, choosing the exact same inequalities, but only changing the word so that you can see the difference. So let's put x greater than 2 here and x greater than -2. All right, just like that. So now we're not so much worried about overlap. We're looking for maybe the solution domain with the most coverage. Okay. So the first solution domain for the inequality x greater than 2 doesn't include 2 and goes up this way. But if we look at x greater than -2, it not only includes the values greater than -2, but also includes 2 and those values even greater than that. So our answer then, our solution, is going to be values greater than -2. Okay, so solutions are going to be equal to -2 to infinity. That's our interval. All right, let's look at some more examples. All right, so find solutions of x that satisfy x less than 2 and x greater than -2. All right, so x less than 2. So now we've got 2 here. Let me use a different color. So here we've got 2. And we want values of x less than 2. So we're going to go this way. And then we've got x greater than -2. So here's -2. We want values of x that are greater. Now, since we're using the word and, we're looking for overlap. So where do these two overlap? They overlap in these two segments on the number lines. So when we translate that downwards, our solution interval is going to be from -2, not including, to +2, and not including, and everything in between. So the values of x that satisfy that compound inequality is going to be from -2 to +2. So notice I'm using parentheses here on both ends because of this not inclusion of -2 and +2. Okay, now let's look at this example. Again, same inequalities, but now it's or. So x less than 2, it's going to be everything that way. And x greater than -2, it's going to be this way. And so now that we've got or, it's going to be any value of x that are in either of those two. And so, we do have some overlap, but basically this first inequality is going to -infinity. And this other inequality is going to +infinity. So the solutions for this one are going to be actually all values of x between +infinity and -infinity. Just like that. Okay. Let me know if you have any questions.